Hi everyone, can you hear me? Please let me know if I'm audible. Okay, great. Sorry for delay. Just a second, let me start. Just a minute, okay? Okay, so you can hear me, right? Okay, so let's start with computer networks today. So I hope that you might have seen some of the videos that I have already uploaded. So there were 4 videos that we have uploaded, right? Okay. If you have not seen, then also it is okay. I mean, we will revise very quickly that what was there in those videos. Okay, so let me start. So today we are going to start with IP addresses, subnetting, and supernetting. Right. So this topic is very easy, and fortunately, like I mean, in every 2-3 years or every frequent year, there is just one question from IP addresses, subnetting, supernetting, and this is very easy topic. So I can say it is very scoring also. And like you should be able to solve these kind of questions. So in fact, in recent gate in I mean gate 2022, they have asked one question from supernetting, right? So anyway, let's just start. Now you might be familiar with this classful addressing and IP addresses and what are all of these, like based on the lectures that I have already uploaded. But maybe let me quickly go through those PDFs that I have uploaded, right? Okay. So we started with the thing that how internet works and all, right? So like I have explained in the video, I mean, that is not much important as per the gate, but it might be little, like you might be little curious that how internet works, right? So that's why I have uploaded like these slides, I have uploaded that part of video. Okay. So then we move to a communication. Let's suppose that you are in some network and there are 2 networks, and you want to access google.com, right? And Google server is is having some other IP, and it is in some other network, and you are here. So like obviously we will see in detail like what are the set of steps. Just a second. So we will see in detail later that what are the set of steps that are required to convert or to communicate with Google server. But one of the key component is that IP address, right? I mean, you are having your own IP address, your PC is having your own IP address, and Google server is having its own IP address. So these are the 2 IP addresses which are called source and destination IP addresses. I mean, you will be sending your packet from here to here. So there will be a source IP address, which is your PC IP address, and there will be a destination IP address, which is Google server IP address. Now, obviously, when you are typing google.com, you do not directly know what is the IP address of that server, and there might be multiple servers of Google, in fact. So there is some service called DNS service that we will look in detail later. But yeah, this service help us from converting this google.com to IP address, right? And then once you get the IP address, you will be reaching to this network, and this network will be replying with the required packet to you. So this is two-way communication. I mean, you are requesting something and it is replying something, right? Okay. So the IP address is basically in different format. You can represent the IP address in different format. One of the format is binary, or another format is called dotted decimal, or you can also represent in hexadecimal, right? So like IP address, if I talk about IPv4, or generally I think in syllabus only there is IPv4. It was IPv6 was earlier, but now they have removed, right? IPv6 was in for 2-3 years. IPv6 was there in GATE syllabus, but now they have removed. Okay. So by the way, my voice is clear or there's some echo in my voice? Because I'm in a different room and that's why I need to just confirm. Okay, ठीक है. So IP address has its own format, right? So in IPv4 we are having 32 bits. 32 bits means like I mean the IP address is 32 bit long. So like generally we represent that in a group of 8s. So this is a group of 8, 8, 8, 8, right? So 8 into 4 is 32 bits. Now if you want to represent in dotted decimal, you will convert each group of 8 into some decimal. Now since it is a group of 8, so let me ask you a very naive question. So suppose, let me ask you this question. Suppose this is a group of 8. Then can you tell me that each number here, if you convert that to dotted decimal, then each number here, can this number be, let's suppose if I write some IP address, can this IP address be something like this? Is this a valid IP address? Answer is no, right? Answer is no, because this 300 cannot be there. So you can have at like minimum 0, and you can have at most 255, because if all are ones, then you will be having 255. If all are zeros, then you will be having 0. So you can have you cannot have 300. In fact, like there was one message, like I mean some fake message or some that so, like generally the fake messages come in the mobile, like you have won the lottery and something. So they said like you won the lottery and with this IP address, and their IP address was something 300 and something. So like I mean I was like, at least you should know that what is IP, like what is a valid IP address before you convey this message. So okay. So anyway, now IP address is the address of the connection or the host or the interface. Like you will get to know what is interface, like once you understand maybe forwarding of the table and all. So each router is connected with the different interface, and like I will clarify two things: what is a subnet, what is interface, what are the supernets in this lecture, right? Okay. Now, IPv4 addresses are unique in the sense that each address defines only and only one connection on the internet. So if two devices are connected to internet, they cannot have the same IP address. If device has two connection to the internet via two networks, then there are two IPv4 networks. So you will see that a router has multiple IP addresses, because router is connected to multiple interfaces. So this router, if it is connected to three interfaces, then it is having three IP addresses. Okay. So if a host or any device is connected to just one interface, it just have generally like our normal day PCs and these things are just having one IP address. But if there is a device that that help us to communicate, maybe router or something like that, right? Then these kind of devices have multiple IP addresses, because these are connected to multiple interfaces. Okay. So anyway, this will be more clear. Let me just quickly go through the slides. So hierarchy in addressing, like generally we have country, state, city, street, like that. Similarly, here we have network ID and host ID. Okay. So any IP address is divided into two parts. One is network ID and host ID. So what does it mean to say network ID, host ID? Let me just tell you. So suppose that there is one IP address, then first I will ask, like suppose there is one address, one normal address, then I will ask in which country this address belongs to, right? Similarly, for the IP address, I will ask that in which network this IP belong to. Okay. So first question that we will be asking, what is the network? So who will ask this question? This question will be asked by, I mean, this question will be asked and resolved by router only, or the devices which are forwarding the packet. So basically, if a packet is coming to some router, then router will first identify that what is the network of this particular packet. So how to identify that network? What you will do, you will divide that IP address based on obviously, like I will tell you some criteria, some subnet mask and all. So basically, you will divide that IP address into two parts. One is called network ID, that will tell you that okay, this is the network that this IP address belongs to. Another one is called host ID, that will tell you that okay, in this network this is the host, right? So that's how it works. Now that are divided into network ID and host ID. So see here, if 32-bit like IP address is 32-bit long, if network ID is n bits, then host ID will be 32 minus n, right? Okay, so first we are identifying, see this arrow is saying first we are identifying which network it is. Then once you identify the network, then in this network, which interface or which host it is, right? Okay. So suppose that your network ID is 8 bits and the host ID is 24 bits. Then how many networks are possible? You might have seen the video, so that's why I'm just quickly going through the slides. So how many networks are possible? 2 power 8 networks, right? 2 power 8 networks are possible. And how many hosts are possible? 2 power 24 hosts are possible. Okay. Like theoretically, these many hosts are possible, but we need 1 2 addresses for the network address and some broadcast address. So that's why I'm just removing 2. Okay. So maybe it will be more clear in the next slides. So anyway, like currently I'm saying 2 power 24 hosts are possible. Similarly, if the network ID is 16 bits, host ID is also 16 bits, then 2 power 16 hosts are possible, 2 power 16 networks are possible. Okay. So classful addressing, yeah. So now let's just move to the classful addressing. What is classful addressing? Is basically like you have your IP addresses. Okay. So let me go to the classful addressing. Actually, these topics are very, very easy once you understand the idea. So in classful addressing, what do you have? You have your IP addresses. I mean, in classful or classless, you have the IP addresses, obviously. So once you have the IP addresses, then if you want to identify that which network it belongs to, so basically there is something called subnet mask that gives you the network ID. Subnet mask will give you the network ID. But if this is classful, okay, then you do not need the explicit subnet mask. If this is class A, then the network ID is initially 8 bits, right? If this is class B, then initially 16 bits, something like that. So basically what we did, like there were, let's suppose there are 32-bit IP address. Then what we did, we have divided this 32-bit, like there are 2 power 32 IP addresses. We have divided these 2 power 32 IP addresses into different parts, which means, let's suppose if I write all 2 power 32 IP addresses here, okay, all 2 power 32 IP addresses, which is, let's suppose, first IP address, maybe IP1, okay, or maybe let me just write IP0 or whatever. So let me just write IP1. This is IP2, something like that, right? IP3, and then finally you have IP2 power 32. So there are 2 power 32 IP addresses. Now what we did, we have divided those 2 power 32 IP addresses into different classes. So I am dividing into this just one half, and I am saying this half, like first half, okay, belongs to just one class, which is class, which class it is? It is class A. So what I'm saying, that I'm dividing my all address space, all IP address space into 2 parts. Currently I'm dividing into 2 parts based on the bit that I have. If the initial bit is 0, see, there are how many bits? This is 32-bit long, right? 32-bit long. So I'm saying if the initial bit is 0, then I'm calling these kind of IP addresses as class A IP addresses. So I will say these kind of IP addresses are class A IP addresses. If the initial bit is 0, if the initial bit is 1, then I will further divide. Okay. So I'm saying if the initial bit is 0, then these kind of IP addresses are class A IP addresses. If initial bit is, let's suppose, 1, then I will further divide this into 2 parts. So currently I've divided into 2 parts, which means, let's suppose that the total fraction is 1, then half of the fraction will be here, half part is here, and then half part is here, right? This is the other half. Now what I will do, I will again divide this other half into 2 parts. I will say that, okay, if the first bit is 1 and then 0 also, okay, if 0 also, then I will say this is my another half. Okay, so I will say this is my another half. If the first bit is 1 1, then this is another half. So I will say that this is my class B. So since I divided, see how I'm going to do, I'm dividing first into this half. So this is the half portion, and then this half also I'm dividing into again other half. Now can you tell me how much portion it is consuming? This class B is consuming 1 by 4, right? Because half I have divided here, and then this is the other half, and this other half also I have divided into 2 parts. So that's why I will say this is consuming 1 by 4th portion, right? Now how much part it is? It is again 1 by 4, right? It is again 1 by 4. Now what I did, I have again divided this 1 by 4 part into 2 other parts. So I said that, okay, let me divide this into 2 other parts, and then I will call, let's suppose if the initial bits are 110, if the initial bits are 110, then I will call this part, and if the initial bit are 111, then I will call this part another part, and if the initial bits are 110, then this is just my other half. So I'm again dividing it to the other half. So this is, let's suppose, called class C. Now, can anyone tell me what is the proportion that class C is having of total networks? This will be having 1/8, because 1/4 is total, and then I have divided that into again two parts. This will be having 1/8. Now this is again having 1/8, right? This thing is again 1/8. But now what I did, I have divided this again further into two parts. I said, like, if it is 111 and then 1 also, sorry, 0 also, then I will say it is class D. Okay, let me tell you explicitly. So I am saying that if it is 111 and then 0 also, then it is class D. If it is 111 and then 1, then it is class E. So I said, like, let me just divide this into another two parts. This is class D, this is class E. So this is 1/8, this is 1/8, right? Sorry, this is 1/8. Can anyone tell me this means this class D will be 1/16, right? Why? Because we have divided, see, we have divided this 1/8 into again two parts, which is again 1/16, right? So 1/8 I have divided into two parts. So basically, like, I mean, if this diagram is okay to you, then it is good. Otherwise, you can represent this by a circle also. So suppose that these are all the networks that I have. These are the IP address 1, IP1, IP2, somewhere, right? IP3, something like this. So these are all the IPs that I am having. Now what I did, let's suppose these are 2^32 IP addresses. Then I've divided that into two parts, and then I said, okay, first half, right? Just this half. Just, instead of using this vertical diagram, I'm just using the circle that is called pie chart, right? So this half I'm calling class A. This half I'm again dividing into two parts, right? And this half I'm calling class B. Now what I'm doing, I'm again dividing into two parts. I'm saying, okay, this is called class C. Now what I'm doing, I'm again dividing into two parts, this one, and then I'm saying this is class D and this is class E. This is D and this is E. Let me know if that is fine to everyone. Okay. So suppose that if I ask you a simple question, suppose that if we pick an IP address uniformly, randomly, then what is the probability it belongs to class D? What is the probability? What will the answer? 1/16, right? Because 1/16 of the portion class D is consuming. Okay, so this portion is just 1/16. See, this is 1/2. This is again okay. Let me write the proportion also. This is 1/2, right? And this is 1/4. This is 1/8. This is 1/16. This is 1/16 again, right? So if you add all of this, it will be it will be just 1, right? If you add all of this, 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/16, this will be just 1. Okay, so I hope you understood this, right? Okay. Now, like, this was just a division, like what we did, like this was just a division, and then they said, like, we have divided this based on the bits, like if first bit is 0, second bit is 10, something like that. Now let's just go and solve this question. Suppose that IP address is divided into 5 classes and ABCD. Okay, so let's just solve this question. Suppose they ask us that if the first bit is 0, then what could be the first byte range of the first byte? Okay, suppose they ask us that what could be the range of first byte, then you will say in the class A first bit. Okay, this is just first bit. Okay, so there are there are 31 other bits also in the class A, right? This is just first bit, which is 0 to be fixed, and there are 31 other bits. Now they are saying first byte, which means like the 7 bits are remaining here, 1 2 3 4 5 6 7, right? Now if all are zeros, then the first byte will be 0. If all are ones, then the first byte will be 127, right? 127. Is this okay to everyone? Now in the class A, like if it is belonging to class A, then there are two ways to identify whether it is belonging to class A. How? If it is given in binary, then by looking just at first bit, you will say that okay, it is belonging to class A. If it is given in decimal or dotted decimal, whatever, right? Then by looking at first byte, okay, by looking at first byte, you will be able to say that okay, this is the class A. How? Let's suppose I say that an IP address is this. Let's suppose I say this is one IP address. Okay, then this IP address belongs to which class? Class A, right? Why? Because the first byte is 90. That is why it belongs to the class A. So basically, based on just first byte also you can say. So suppose that if I find out that if the class B is having initial 10, then what should be the range of this class B? The first byte range. Then you will say if all are zeros, then I think it is 128. If all are ones, then it will be like if all are ones, then you will say that okay, like it should be 255 minus, since it is 0, right? Then you need to subtract 64, so it will be 192, sorry, 191, right? Okay, so this is the range. Now similarly, if you find out for the class C, I mean you can find out, that's not a big deal. So I think I do have in the slides only, so let me go through the slides. Okay, I have the slides on the next page probably. Okay, so basically based on just first bit or first byte also you can tell whether it is class A, class B or class C, something like that, right? Okay, now basically in the class A or class B or class C, we are having fixed number of bits for the network ID, fixed number of bits for the host ID. So let me tell you. So if okay, before that, if I just ask you to find the class of this this address, then I think you can easily able to find, right? This is class A because this is 0. And similarly, if I just ask you to find out, then you will say, okay, this should be class. If you do not remember exactly, then what you can do, you can say that, okay, initially zeros and then ones. This was the class A. Then in one also, I have divided into 10 and then 11. This is class B. And then in 11 also, I have divided into two parts, 110, 111, right? This is class C. In 111 also, I have divided into two parts, 1110, 1111. So this is class D, this is class C. So basically, they are saying 110. So 110 is class C, right? It is class C. So you will say the answer is class C. So first two bits are 1 and the third bit is 0. That's why the answer is class C. Okay. Similarly, based on the first byte also, you can find out that this is in between this. So it should be class D, something like that, right? Great. Now, in these IP addresses, like ABC, for these classes, we have divided into two parts. I mean, for every IP address that belongs to this class, we have divided into two parts. One is network ID, another one is host ID. So network ID and host ID are not applicable for D and E class. In fact, this E class is was reserved for the future use, and D is for the multicast address. You will get to know this multicast in the future lectures. But these network ID and host ID, these are only applicable to this class A, class B, and class C. Okay. So in fact, this classful addressing is not even in the use, but just for the sake of theoretical knowledge, we will just go through these classes. So if it is class A, then initial 8 bits are network ID. If it is class B, then initial 16 bits are network ID, like that, right? If it is class C, then initial 24 bits are network ID. So what do I mean by network ID? Let's suppose that I do have some IP address. So this is the range. So suppose that I do have some IP address. Okay. So maybe let me take one IP address. Okay. So suppose that this is the IP address that I have now, which is 23.56.7.91. In which class it belongs to? This belongs to class A, first of all. Why? Because this byte is basically between 0 to 127. So this belongs to class A. Now, since I know that it belongs to class A, what I will do, I easily know that what is the network ID. Network ID is first 8 bits. So this is network ID. What is host ID? This is host ID. So what do I mean by network ID and host ID, right? So it means that what you will do, whatever is in the network ID, you cannot change it, which means it is fixed. So if the IP address is this, which is 23.56.7.91, then you will say that this IP address belongs to one network, first of all, right? Then you will say, let me just write it, that this IP address belongs to some network, and we can also find out what are the other hosts. Like this is just one host, okay? So we can also find out the whole range of those IP address that is in this network. So what I will do, I will keep this network ID to be fixed. So basically this network ID is fixed. You cannot change this 23 because the first byte is fixed, which is network ID. You can change all the bits in the host ID, which means you can take all the zeros and you can take all the ones like that. So if you put all the zeros here, you will be getting this. If you put maybe okay, let me write in binary, okay, let me write in binary. Maybe let's suppose, like if you put one here, you can put anything here, right? So you can put anything here, 0 0 0 1 0. So basically from 23.0.0.0 to 23.255.255.255, this is the range of IP addresses that belongs to this network. So this IP address belongs to just one network, and not just this IP address. There are many other IP addresses that belongs to this network. And how many? These many, right? So I hope I'm able to convince you. So basically, like given the IP address in the classful addressing, you can first find out the network ID. And once you find out the network ID, you will say that you cannot change it. It is fixed, right? It is fixed. You cannot change it. Now you can change all of this from 0 to 255. Now, can anyone tell me how many IP addresses that are there in this network? Okay, so suppose that my IP address is this. That is one host IP address, right? So how many IP addresses are there in this network? Okay, Tejas is saying, sir, can you please repeat once how to find belong to which IP address by seeing the directly decimal number? See, like suppose you know that a bit, like based on the bit we have classified. Now if first bit is 0, then the other bits, like in the first byte only, it could be all zeros to all ones. So if you put all zeros, it will be 0 only, right? If the first bit is 0, if you put all other 7 bits as all zeros, then it will be 0. If you put all ones, it will be 127. So the range here, I'm not telling you the fixed number. Here I'm telling you the fixed bits, but here I'm telling you the range, right? So 0 to 127. Similarly, if the first two bits are 10, then you can say it is class B. Or maybe if it is given the decimal, then you will keep them at 0. So these are the 6 bits that you can change. So if you put all zeros, then it will be 128. If you put all ones, it will be 191. So if the first byte is between 128 to 191, then it is class B. Something like that, right? Okay. So how many IP addresses there? Now you will say that this IP address is just one of the IP address in whatever network it belongs to. So it belongs to one of the network. Now, if you ask me that how many IP addresses there, I will say that let me fix this. Okay, let me fix this. You are going to fix this. And then you will say that remainings are this. Whatever is the remaining, let me just write with the dash. So these are the remaining bytes. Now, how many numbers it can take? It can take from 0 to 255, any number. Like since I'm saying that you can change this, right? You can change all of this. Okay, so it will be 0 to 255 means 256. It can also take 256 numbers. It can also take 256 numbers. So it is 2 power 8, 2 power 8, 2 power 8, which is it is 256 into 256 into 256, which is 2 power 24. So 2 power 24 IP addresses are there in this network, right? I hope you understood. So basically, given this IP address, like you can also tell that which network it belongs to. Network means you can tell the network ID. So network ID is something where the all host IDs are 0. So if I tell you the network ID, then you will say the first address is always the network ID. So this is the network ID, right? Now you will say that this host belongs to some of the network. Since it is classful, then you can, like, your first step is that, okay, it is classful. First, identify the class. It is from class A. Then, since it is from class A, you can say that, okay, the first host IDs are fixed. Now you can, sorry, network IDs are fixed. You can change the host IDs, right? So it is network prefix or network ID. You can change the host ID. Now, if it is all 0, then it used to represent the network. So which means 23.0.0.0 is called network ID, and any other ID, like some random ID, something like this is just some one host, right? Okay. So I hope you got it. So if it is from class A, let's suppose if it is from class A, then the first byte is fixed, right, for the network ID. How many bits you can change? You can change 24 bits, because 8 bits are fixed. I mean, fixed in the sense that if they give you 23, you cannot change anything from 23, right? It is fixed. You cannot change anything from 23. Okay. So fixed means this. Now, how many bits you can change? You can change 24 bits. So if I just ask you, given any network, okay, if I just ask you that given any network in class A, given class A, how many IPs are possible? Then you will say that, see, like if it is from class A, then I can, given any network means, first of all, the first byte is given, right? So first byte is given, which is maybe 50, maybe 23, something like that. Then you can change all these 3 bytes, which means you can change these 24 bits. In terms of bits, I will say 24 bits, right? If you can change these 24 bits, that means each bit can take either 1 or 0. That means 2 power 24 IP addresses are possible. Okay. So that's what we have already seen in the theory lectures also. Now, given this, let's suppose they are asking about the mask. Okay, mask is basically like mask is telling you that how many bits are fixed. So for the network ID, corresponding to network ID, you keep mask like all bits are 1. Corresponding to host ID, you keep all bits are 0. Then that's how you calculate the mask. So suppose if I ask you what is the network mask or subnet mask, okay, doesn't matter. So either you call it network mask or subnet mask. I mean, by default, you call it anything. I mean, subnet is also a network, so it doesn't matter. So let's suppose if I'm calling network mask, subnet mask, does not matter. If I want to calculate the network mask or subnet mask, then what you will do, you will say that, okay, the first byte, like it is the first byte, I will keep all the ones in the first byte, which means it will be just 255. Why? Because it is class A. So for the class A, what is the network ID? Network ID is this first byte. That's why I will keep all the ones in the first byte and all the zeros in the host ID, which is all the remaining bytes. So what is the network mask? It is 255.0.0.0. So there are a couple of things that we have seen. I mean, given any IP address, you can find out what is the class of that, right? You can find out what is the network ID. So let me just write. So given any IP address, which of the following you can find? Let's just take it as a question. Which of the following we can find, right? Now, one thing is that, let's suppose option A is saying that you can find class name. Okay. Option B is saying you can find maybe network ID. Option C is saying you can find host ID. Option Okay, in just a second, right? Okay, so this mic has got some problem, I think. Is this audible now? Okay, is this still audible? Okay. So okay. Okay, I hope it is audible now, right? Okay. Or this is not. Yeah, this is audible, right? Okay. So which of the following you can find given network ID, no, given IP address? I think you can find all of them, right? I mean, okay, let me just write. There is something called default subnet mask or the subnet mask only. So let me just write default if you are very much particular. I will clarify this after the subnetting, but yeah, there is called default subnet mask. So which of the following you can find? You can find all of them, right? So you can find the class name, you can find the network ID, you can find the host ID, you can find the default subnet mask. So what is subnet mask? Subnet mask is basically something which is telling you that which bit are fixed or which bit are you can change. So basically we might not be using subnet mask anywhere, like for our calculation purpose. We will be just using, okay, which are fixed, which are the changeable bits. But how we use it theoretically is basically something like this. Suppose that they give you this, then they will say that, okay, if the subnet mask is for this, let's suppose the subnet mask you can easily calculate, which is 255.255, right? Sorry, 255.0.0.0. So the subnet mask will be 255.0.0.0. Okay, this is the subnet mask. Then it is basically used to have a AND with this. So there's a bitwise AND with these two numbers to find out the network ID, right? So if you do AND of this, then what you will be getting, bitwise AND, you will be getting 23.0.0.0 as a network ID. So this subnet mask is basically used to just find the network ID and the network ID only. So given a subnet mask, you can find the network ID, but we will not be using this method, which means like we know the how to calculate the network ID. How to calculate? Like using the class, we know that, okay, this is fixed, so I can easily calculate the network ID, making the all host IDs are 0. But this is not how computer does, or computer or the router or any algorithm for that purpose, right? So the algorithmic perspective, they will say that, okay, this is your network ID, then they have the subnet mask basically in general. So what they does, they basically do the AND operation, and then they finally find out the network ID. Okay, so there is no audio, there is audio. Okay, Okay. Please let me know if there is any disconnection. Maybe that mic is not charged. I will use some other mic if in that case. Okay. So this is 23.0.0.0. Okay. Now this like that is a use of subnet mask. So I hope you are okay that how to use a subnet mask. So basically, in general, routers has subnet mask, and they use it to find network ID. So like why they need to find the network ID? I mean, like see, I'm assuming that you have seen already the videos that I have already uploaded. So based on that assumption only, I'm throwing the terms here and there. So they used to find the network ID to forward the packet, right? Okay. Now let's just move to some other slides. So suppose that this is given the address, default mask for this, and then find the beginning address. Beginning address means the network address. So can you tell me the beginning address or the network address for this particular IP address? See, it is from class B. That is why initial 2 bytes are fixed. Since the initial 2 bytes are fixed, you can change any of these bytes. But I'm just interested in the first address. You will say for the first, it is 00, right? So I will say this is the subnet mask, and then finally I find the first address, which is also called the network ID. Okay, for the class C, what will the first address or the network address? It is 201.180.56.0. Why that is the case? Because that is class C. So that is why first 3 bytes are fixed. So you can only change the last byte. So that is why you will say that it is .0. Now, the default mask is this. Okay. Now, this idea of classful addressing is basically not a very popular idea for very obvious reasons. Okay. So Sandeep is asking how to identify the subnet mask. So if it is class C, then you will say the subnet mask will be like, since these bits are fixed, right? These bits are fixed. So subnet mask will be whatever is fixed, wherever it is fixed, you will be writing 1 here. So if you write once in the binary, if you write once everywhere till this 3 bytes, then it will be 255.255.255, and wherever it is changeable, you write 0. So it will be 255.255.255.0, right? So wherever it is fixed, so how to identify what is fixed? In class C, initial 16 bits are fixed. Given any address, initial 16 bits are fixed, right? So that's how you identify the subnet mask. So subnet mask is basically like just used to calculate the network ID, which means let's suppose that this IP address is given to us. Then first I will find the subnet mask. I mean, theoretically that's how the computer or the router does. So they first find out the subnet mask, or in fact they has the subnet mask, and from this subnet mask they find out the network ID. How? What they will do? They will take the IP address, and if they want to find out the network in which this IP address belongs to, what they will do? They will take the IP address, they will take the subnet mask, and the subnet mask in this case is 255.255.255.0. They will take this, and they will perform one operation, that is bitwise AND. They will perform the AND operation in the binary. And then finally, since it is 1 1, all the ones, right? In the binary, it is all ones, all ones, all ones. So since it is all ones in the binary, it will be just, if you take the AND, it will be just like this. And since it is all zeros, it will be just 0. Okay. So this is called network ID. I mean, that's how the router used to find the network ID. Okay. So let me go to the slides that we have here. Now, in this classful addressing, we have seen that what is a class, how to identify the class, right? I mean, let me just summarize that what okay, so let me not use this. Just a second. Okay, am I audible now? So in the classful addressing, we have divided all IP addresses into classes, right? Each class, can be basically each IP address belongs to just one class or something like that, right? I mean, you can identify each class has some fixed starting bits, something like this, right? Starting bits. Each class has fixed number of bits for network ID and host ID, right? So basically, what is happening now is that let's consider class A. Okay, let's consider class A. In this class A, if I just tell you that any IP address that it belongs to, let's suppose any IP address it belongs to class A, then you will say the first 8 bits are fixed to be network ID, and then remaining bits are for the host ID. So what does it mean to say that these 8 bits are for network ID? Let's suppose it is anything. Let's suppose it is maybe 35. Okay, something like this. This is belonging to class A. Now, which means that there is a network, that network ID is 35.0.0.0. Okay, and this network, this just standalone network is having how many hosts or how many IP addresses? It has 2 power 24 hosts, right? It is having 2 power 24 hosts, so which is huge. I mean, for any organization, if it is having a class A address, then these number of IP addresses or these number of hosts are just a huge number. Why? Because for any organization, even in today's class, until today also, like for, I don't think that any organization contains that these many hosts, right? Or these many, they needs these many IP addresses. So basically, for any organization, these many hosts are too much. So that's why, let's suppose that you require only, let's suppose 200 hosts, or maybe let's suppose you require 500 hosts, right? If you require 500 hosts, then if someone give you that, okay, you can take the class A address, then class A is basically having these many hosts, then you are actually wasting. If you're using the class A, then you are actually wasting. You're only utilizing 500 IP addresses from here. You're actually wasting these many addresses, right? These many addresses will got waste. So basically, for any organization, if they are taking class A IP address, then first of all, there are only how many networks are possible? Since this is just 8 bits, now tell me how many class A networks are possible? Since these are just 8 bits, so you will say only 2 power 8 networks are possible, first of all. Secondly, that in each network, okay, in each network, we have 2 power 24 IP addresses. So both are not desired, which means like only these, which is just 256 organizations can have IP address of class A, and these organization has to be so big because this is containing 2 power 24 IP addresses, right? Every class is containing like every network is containing 2 power 24 IP addresses. So that's why like almost nobody uses this class A addresses, because nobody has these many IP addresses. I mean, no organization has these many IP addresses. So now similarly, if I go to the class B is also having some other problem. So let me write the class B. Now in the class B, how many how many networks are possible? If you are having 2 bits are fixed, 2 bytes are fixed, which means like for the network ID, you have 16 bits, 16 bits for network ID, which means that you can have how many networks? You can have 2 power 16 networks, right? If you can have 2 power 16 network, and in each network, how many IP addresses you need to have, you will be having again 2 power 16 IP addresses. Why? Because 16 bit is network ID and 16 bit is host ID also. So if these are 16 bits, you can change any of the bit and there will be 2 power 16 networks that are possible. So again, this 2 power 16 is also a huge number. Okay, I mean 2 power 16 IP addresses is also a huge number. Now, no organization have these many IP addresses. Okay, most of the organization have very less IP addresses, which is, I mean, which is at least not in the range of 2 power 16 or something like this. Now, let's move to class C. If I just ask that for the class C, how many networks are possible? Then you will say for the class C, since 16 bits are available, oh sorry, 24 bits are available for the network ID, then you will say 2 power 24 networks are possible, and 8 bits are available for the host ID, then 2 power 8 IP addresses are possible. So which is just 2 power 256. So again, like I mean, generally, if I need, let's suppose 500 IP addresses, then which one you will give me? If I need 500 IP addresses, then you cannot give me class C address. Reason being is that for the class C, I can just have 256, right? If you give me class A, then class is having many IP addresses. Every network of class is having many IP addresses. So maybe you will give me class B IP address, right? Now, let me ask you a question, which is something like this. If some organization need 500 IP addresses, then how many IP addresses you are wasting? What is the answer? Anyone? First of all, which class IP address you will give me? Can you give me class C? Class C class C network are just having 256 hosts, 256 IP addresses or 256 hosts. Let me write, right? So you cannot give me class C because it is just having 256. Can you give me class B? Can you give me class B? Okay. So class B is having 2 power 16 hosts. Yes, you can give me class B. Can you give me class A? Then yes, you can also give me class A, but that's too many, right? So so let's not use class A. So you will give me class B, obviously, like optimally you will give me class B, and I will be having 2 power 16 hosts or 2 power 16 IP addresses to use, but I just need 500 IP addresses. So I will be wasting these many IP addresses, right? These many IP addresses will be wasted. So that was not just a problem for one organization. This is the problem for many other organizations. So that's why there were many wastage of the IP addresses. That's why like this kind of addressing, which is classful addressing, is not very suitable. Class A has 128 networks. Class A, yes, Class A has these many networks, but I'm asking how many host or IP addresses that it has. It has 2 power 24 IP addresses, right? If 128 networks. Okay, so just a second. There is one typo. This is having, yeah, so first bit is fixed. So basically the first bit is fixed. So that is why it is just having 127. Why? Because first bit is fixed. Okay. So similarly here 2 bits are fixed. So that's why it is having 2 power 24 or 2 power 14 networks, because like I mean yeah, 16 bits are for IP addresses, but out of them 2 bits are fixed basically. So basically the 2 bits are fixed, and that is why I will be just having 2 power 24 or 2 power 14 networks. Is this okay to everyone? Okay. Similarly here, how many bits are fixed? Here, can anyone tell me quickly? 3 bits are fixed, right? 110. So 3 bits has to be 110. That's why it can have at most 3 bits are fixed, 24 bits are for network ID. So that's why it can have 2 power 21 networks. Okay. Yeah. So I hope everyone understood this question, that how we are calculating the wastage. So Manideep is asking, 2 IP addresses are fixed, not the 2-bit position. No, here in the class B, the 2 bits are fixed. Initial bit is 1, and then second bit is 0. That's fixed. You cannot change it. Like that's the identifier for class B. And then for the network, you have 16 bits. So remaining 14 bits you can change for the network, right? This is representing, I mean, this whole is representing the network ID, but you can only change these 14 bits out of them. So which means how many networks are possible? You will say 2 power 14. And then how many hosts are possible? These are 16 bits that you can change for the host. So 16 bits you can change for the host. That's why 2 power 16 IP addresses are possible. Okay. So since there was too much of wastage for most of the organizations, that is why this idea got absolute, or nobody is using that idea. So class A, this class is basically having only 128 organizations in this world. Why? Because one bit is fixed, which is to be 0, and then you can change 7 bits. So only 128 organizations can have this class A network. Can be assigned to only 128 organizations, with each organization is having these many hosts, which is 2 power 24, these many hosts, which is too much, right? So in fact, nobody has these many hosts. So similarly, that's the problem for class B. I mean, class B addresses are designed for mid-size organization, but many of the addresses are also remain unused. For class B also, like if I just need 500 addresses, then I will be using class B, and too many addresses, which I have just shown, like 2 power 16 minus 500. These addresses are wasted here. So in the class B also, many addresses got wasted. So that's why, like, there is no point in using this class full addressing. In fact, this is just for the theoretical purpose we have seen it. I think it is just used in 1980s, and after 1980s, in fact, the whole internet evolution was after that. So like nobody is using this classful addressing like till today. So we are using classless addressing. So that we will see, right? So I hope you are convinced that why not to use this classful addressing, because there was too much of wastage of the addresses. Now there is something called classless addressing. Here there is no class, hence network ID or the prefix is not implicit. So earlier what used to happen? Earlier we were having the fixed network ID, that given a class A, how much is the network ID? Class A was having 8 bit for the network ID, right? Something like this. But here, since the class is not fixed, that is why I cannot tell directly that what is the network ID, okay, or in which class it belongs to, since there is no class, right? So that's called classless addressing. That's that's very nice, and that's only the thing that internet uses in today's world, right? So let's just see that what it is. So suppose that I say there is some IP address, and then you will be writing some IP address, maybe x.y.z.w, and then I will specify what is the network ID with some number. So I will say, let's suppose initial 17 bits or maybe initial 16 bits are fixed. If initial 16 bit is network ID, then I will say that with n value will be 16. Okay, if the initial 16 bit is a network ID. So basically, like in the classless addressing, I explicitly have to tell that what is a network ID. Earlier, the network ID was implicit. That's the only difference. And it will make everything, this implementation, everything very convenient. Okay, let's just see. So basically, here I will say that this is the IP address, and I have to tell what is the network ID. Then I will say that initial 8 bits are fixed. So the network ID is this. So suppose I say that initial 8 bits is fixed, then the network ID will be, can anyone tell me the network ID here? So if initial 8 bits are fixed, then I will say that this IP address belongs to some network, and since initial 8 bits are fixed, then you can change any of these bits, right? And then there are many IP addresses in this range. Many IP addresses. One of the IP address is 0. I'm writing in decimal, 0.0.0, 255.255.255 is other IP address. In between somewhere, this IP address is also there, 12.24.76.8. So basically, if you're writing /8, it means that network ID is first 8 bits, okay? And then you can change any other bit. So you can change any other bit to 0 or 1, whatever. So if you change all to zeros, then this is the first address, and this is last address in this network ID. So this is last address. Okay, I hope you understood. In between, there is this particular IP address is there. Okay, so given any class earlier, I could have told the first address and last address. Similarly, given the network ID or given the prefix, okay, this is called slash notation. Okay, that's called prefix length. So given any prefix, I can also tell the /8, then it means I can tell the network ID, I can tell the total number of addresses here. So how many total number of addresses are there? How many bits you can change? 24 bits you can change. So 2 power 24 IP addresses are there in this particular network. Okay. Similarly, here also you can find out the similar things. Let's suppose here I need to find out that what is the network ID. Okay. And what is the first address, what is the last address, something like this. Suppose. So it is saying that initial 12 bits are fixed. So which means this is 8 bits. And then from here, 4 bits are fixed. Can you convert this 14 to binary? So maybe it is 8 plus 2, 8 plus 4 plus 2, right? Yeah. So which means 14 will be 2 power 0 is 0, 2 power 1, 2 power 2, 2 power 3. So 1, 2, 3, 4, 5, 6, 7, 8. This is 14, and then 23 dot this, and then okay, I'm writing these bits you can change. So basically you can change after the 12. So 8 and then these 4. So after this you can change, right? Okay. So this is 14, and after it, is this 14? Yeah, this is 14. So after this you can change, which means that if I just ask you what is the first IP address, then you will say the first IP address here will be 23 dot, these are 4 zeros. Basically I'm writing in mix of binary and the decimal, but I hope you understand, right? Just for the sake of convenience I'm writing. Okay, these things are fixed till now, everything is fixed, and then you will say 0 0 0 0 and then dot 0 dot 0. Okay. Now, can anyone tell me what is the last IP address here? You will see till now everything is fixed, and then you can only change. So these things are fixed. You can only change after it, which means you can say that after it this is 1111. Okay, this is the last IP address .255.255. Yes, that is right. So this is the first IP address. This is the last IP address. So here they will tell you explicitly what is the prefix length. Prefix length means that what is the network ID, they will tell you. Okay. And for the routers, it is already known, right? Routers knows this. Like I will tell you that how to forward the packet and how does the router know. But router knows this, and then based on this, they will calculate, okay, in which network it actually belongs to. So like for the router, this IP address will come and they will calculate this first IP address or the network ID. This is also called network ID. How they will calculate? They will just do the masking with the subnet mask, right? How they calculate subnet mask? Can anyone tell me the subnet mask here? Given this, what is the subnet mask? You will say initial 12 bits are fixed. I mean, initial 12 bits are ones. Whatever is the fix, it will be 1. Right? These are 8 bits. Then this is 4 bits, and then 0 0 0 0 dot 0 dot 0. So basically, subnet mask will be 255 dot. This will be I think like you need to subtract 2 power 0, 2 power 1, 2 power 2, 2 power 3, you need to subtract 15 from 255, which is 240. Yeah, dot 0 dot 0. So this is your subnet mask. How we are calculating the subnet mask? We are just going for one thing, whatever is your network ID. Okay, the initial 12 bits are just 1, everything else is just 0. That's how you can calculate the subnet mask. Okay, so let me go to the slides only, maybe. Okay. So here, like for these questions, first address, last address, you can find out, right? Now, suppose I need to find the number of addresses, then how you will find the number of addresses? You will say that, okay, this is 27, then 27 bits are fixed. You can change how many bits? 5 bits, which means 2 power 5 addresses are possible. And then what is the first address? You can find out the first address, you can find out the last address also. So this address, first address, last address, these things you can find out, right? So these examples are from Frozen book. Most of the time I have referred Frozen. Sometimes I have referred Tenenbaum also. Sometimes I have referred Croge also. So 3 books I have referred in this particular course, like I will be referring. Sometimes, like most of the time, I will be referring Trojan, but if some concept is there in the crows, I have taken from crows. If some concept is there in the Tenenbaum, I have taken the concept from Tenenbaum. So Tenenbaum is for networking also. Tenenbaum book is for operating systems also. I mean, in operating system also, somewhere here and there, I have referred, or I or Vishal has referred Tenenbaum, and in networking also, I will be referring Tenenbaum. Okay. So this is first, last, something like this, right? Okay, network address. The first address is the network address. It is used to route the packet to the destination and all. So there are two things. One is directed broadcast address, limited broadcast address. A limited broadcast address is fixed 255.255.255.255. It means that if a host inside a network is broadcasting, it is called limited broadcast address. Directed broadcast address is basically last address of the network. It is used for the other host which is sending to some network, which is like the host is from other network. It is sending a packet to a complete network in some other network, which it particularly do not belong to. So that's where it will be using direct broadcast address. Okay. So limited broadcast address is fixed. Directed broadcast address is last address. Network address is first address. So given this, if I just ask you what is directed DBA, which means the last address. If I just ask you what is network address, which means the first address, and if I ask you what is limited broadcast address, you can find out, right? Okay. So suppose that this is given to me. Suppose that this is given to me. Then obviously you can find out the first address or the last address, which are something like this. So 223.1 is your first address. So let me write 223.1.0.0 is your first address, right? Similarly, 223.1.1.255 is your last address. It is your first address. It is your last address, right? Now, given this, you can find out the first address and last address. Now, let me take some other address in this range. Can you give me any address? Maybe 223.1. Maybe this is 0. Okay. Let me take any address. Maybe 1.220. Okay. Then /23. So basically, what I'm saying is that you take any address, maybe this address in this range, then you can represent this is a network, right? This complete thing is a network, which means there is a first address, last address. I mean, first address is your network address or the network ID, network address. This is your broadcast address, like this. So this complete thing represents a network. Now, given this just one IP, right, which was 223.1.1.108/23, you have found out all of the things of the network. Now, suppose if I give you any network in this, any ID in this particular network, which is something like this, then can you find out the whole network using this ID also? Yes, right? Either they give you this, or they give you this, or they give you anything which is in this particular, maybe this one. Okay, just a first address, maybe last address, anything they give you. Okay, in this network, you pick any ID and then /23 represents the same network. Okay, you pick anything and then /23 in this range, you pick anything. Maybe let's pick 223.1.0.maybe 5. Okay, that's there in this network, and then /23. This also represents the same thing that it represents, which is 23, 223.1.1.1.8/23. So these things represent the same thing, which means you can take any IP address from this and then you just do the /23. This will represent the same thing, right? Okay. Yeah, that was in the lecture 2. Now let's just move to the subnetting. So what is the subnetting? Subnetting is basically making your, let's suppose that some network is there. Okay, this router was connected to, let's suppose, all of these PCs directly earlier. Now what I want to do, I want to basically have some lesser workload to this router, maybe. Okay, then I will just divide that networks into the subnets. So what will happen? Earlier what used to happen, let's suppose, okay, earlier this was the picture where this router was directly connected to Okay, all of these servers. So basically you can say that this router is connected to all of these. Okay, maybe this all of this was directly connected, which means like how many, whatever is the number of hosts here, it was, let's suppose, directly connected. Now what we did, we have divided these networks into the sub network. I said like this router will not do too much of headache. Too much of headache means what? Like there is something called router protocol. I mean, given if a packet is coming to that, then earlier what used to happen, it had to calculate that which host this packet belong to. Let's suppose this packet is having some particular IP address, right? Then it will calculate something called as MAC address using the ARP or something, right? Like we will see this later. So basically this router will send this packet to one of the particular host. Now this router is saying that too many packets are coming to me. I need to again and again calculate the MAC address or something. Then I will not take too much of headache. I will just forward this packet to one of the router. And then this one of the router will do what? This will calculate the MAC address, right? Earlier this was calculating the MAC address, but now this will calculate the MAC address. So this is just one requirement. I'm not saying this is the only requirement. So basically this is just one requirement where the packets are coming to this router. And now I'm saying that instead of this router calculate all the MAC addresses for every packet, this router this router divide its task to other routers, right? Now this router will send, if the packet is belong to this network, this router will send the packet to this router. This router will calculate the MAC address now. This is just one requirement. What could be the other requirement for the subnetting? Can anyone guess? Maybe for the security purpose, which means that if a packet is coming to, let's suppose, this department, which is highly secured, then this router will be having extra security protocol. Let's suppose this is highly secured. These are the highly secured area. Okay, high secure. Then this will be having extra. This particular router will be having extra algorithms. Okay, or extra routing, extra security protocols. Or some firewalls where it will be checking that okay, these particular IP addresses are allowed or something is not allowed, something like that, right? So basically there could be some other requirements also, but the subnetting is used to divide a network into different particular parts, such that the router does not directly connected to the host that it was connected to earlier. Instead it will be connected to some other forwarding device. Okay, so let's just see that how does it work. Suppose they say that divide this network into 4 parts. Now first tell me how many IP addresses are there in this network. In this particular network, 2 power 8 IP addresses are there. And then, which means 256 IP addresses are there. Then I will divide this. They want me to divide into 4 parts. Maybe I will divide it into each is having, let's suppose, 2 power 6, right? Which is 64. So let's suppose I will divide it into 2 power 6 IP addresses. I will divide this particular network. Okay, this particular network is, let's suppose I'm representing this network with a pie chart. Pie chart means like there are IP1, this is some IP1, IP2, like that. I will say that okay, let me divide all the IPs into 4 parts. Okay, so I will divide it into 4 parts. How you can divide? So what you will do, you will take this. Okay, this is 24. Let me write it on the next page also. Maybe you have seen the lectures, right? So I can go through the slides so that I can switch to the questions directly. Okay, so this is network ID, this is host ID. Now what I will say that, see, this is the network ID. You want how many networks? You want 4 networks. So I will borrow something like some number of bits from the host ID. If you want 4 networks, then how many bits I will borrow? I will borrow 2 bits, right? I will say that okay, here 0 0. If these 2 bits are 0 0, it will represent my subnet 1. It will represent subnet 2, like that, right? So I will divide something like this. This was the earlier case. Now I have chosen 0 0. Then I will say that okay, this is subnet 1. Okay, which means that from 0 0 to these 0 0 are fixed. Okay, these 0 0. See here, these 0 0s are fixed. Should I tell that on the slide? I mean here. Or is this okay to everyone? Okay, so basically, like I was expecting that you might have seen the lectures. Okay, let me know if there is any doubt. That's fine, right? So if you have seen the lectures, then it should be fine. So it is 0, 0. It means like these 0, 0 are fixed, and then you can, if all are zeros, then this is just a first IP in that subnet. If all are ones, then this is the last ID, last IP in that subnet. So this is all about just subnet 1. Similarly, if you take this 0, 1, then this is all about subnet 2, which means the first ID where this 0, 1 is fixed, right? This 0, 1. You see here, this 0, 1 is fixed. Similarly, this 0, 1 is fixed, right? I hope you can see my cursor. So this 0, 1 is fixed. Now, similarly, I will be having like 4 subnet here, 0, 0, 0, 1, 1 and 1, 0 and 1, 1. These are my subnet numbers, and subnet ID based on that I will calculate. And then there are many things I can calculate: host range, directed broadcast address, which means this is just a first address, this is the last address, number of hosts, which means like a number of IP addresses, whatever the number of IP addresses are there. If I just subtract 2, then you will get the number of hosts, right? Why? Because one IP address you will be using for subnet ID, another IP address you will be using for broadcast address. So that's why you need to subtract 2. Okay. And suppose they ask me to divide into 10 hosts. So 10 host means how many bits you need to borrow. If you borrow 3 bits, then it will be just 8 hosts. If you borrow 4 bits, then there will be 16 hosts, right? So that's why you have to borrow 4 bits. Okay. Okay, they want they want 10 hosts. They don't want 10 network, they want 10 hosts, okay, per network. So if they want 10 hosts, then if the host ID is 5, then there will be 32 hosts. If the host ID is 4, then there will be 16 hosts. If the host ID is 3, then there will be 8 hosts. You want 10 hosts, so how many host ID you will be needing? You will be needing 4-bit host ID. So how many such subnets are possible? 4 bits are subnet here because 24 bits are fixed, and then these 4 bits you need for the host ID. Then the middle 4 bits will be for subnet. So that's why the 16 subnets are possible, 2 power 4, right? Okay. So this was there. Yeah, these are the 16th subnet. Okay. So now let's see this question. An organization granted, okay, this question I have taken from Frozen. An organization is granted a block of address with the beginning address this. So they are saying that our organization is having beginning address this. The organization needs to have 3 sub blocks. Okay, so what organization wants to do? It has some pool of IP addresses, which is this, right? So let me go here. See, it has a pool of IP addresses. There are many IP addresses in this network, which are, can anyone tell me how many IP addresses are there? There are 2 power 8 IP addresses are there, right? In this pool. So it is having a 256 IP address, this organization. This organization need to divide those IP addresses into 3 sub-blocks of the addresses to use in its 3 subnets. So what they want to do, they want to divide these 256 IP addresses into 3 set. I mean, this pool into 3 pools. One sub-block of 10 addresses, one should be having 10, another one should be having 60, another one should be having 120. Okay, so which means they are just using 190, and then they do not care about the other IP addresses. So 256, there will be some other IP addresses, they do not care. They just want one subblock to have these many IP addresses, another subblock to have these many IP addresses, another subblock to have these many IP addresses. Now, what is the maximum number of IP addresses that you need in one subblock? 120, right? So always first write in the decreasing order. 120 you need, and then you need 60, then you need 10. So this is first block, this is second block, this is third block, right? Now you need 120 IP addresses in one of the block. So can anyone tell me, if I need these many IP addresses, then what should be the host, what should be the number of host bits? Okay, so it should be 7 bits, right? 2 power 7 will be 128 in the host bits. So it should be, why 8 bits? No, you just need you need 120 IP addresses there. So you just need a host ID, you just need 7 bits in the host ID, right? So you just need 7 bits in the host ID. So which means, let's suppose that you need 120. So first thing is to note here is that you have to, okay, you have to write in the decreasing order. You don't miss it. This is the first thing. Okay, if there is a variable size of network, which means one is having 10 hosts, one is having 60 nodes, 60 hosts or something like this, then you see what is the biggest network. First assign to the biggest network. Now, one of the network is having 120 hosts. So you will say, what is the IP address here? IP address is this one. Okay, so maybe let me write this IP address on the next page. So you are saying here is that 24 bits are fixed. So these bits are fixed, which means 14.24.70. These bits are changeable, right? These bits are changeable. Now you need 7 bits for the first block, right? So which means this 4, 5, 6, 7, right? You need these many bits for the first block. So which means you can say that first block, I mean, you need these many bits as a host ID. So can anyone tell me what should be the network ID for the first block? So you can say the network ID of the first block should be, can anyone tell me? Yeah, 0 or 1. Yeah, very nice. So it could be 0 or 1 in general. I mean, you can pick 0 to be I mean, what you can do, you can pick this 0 and you can say that for the network ID, I'm picking all of them as a network ID, and I'm saying that this particular block belongs to my 120 host, which means I will say that, let's suppose I'm saying if it is 0, okay, you change anything. These are the 7 bits that are remaining. 4, 1, 2, 3, 4, 5, 6, 7. If you change anything, this represents you how many set of IP addresses? This represents you 128 addresses. Out of them, I just need to use 120. That's fine. Okay, this is one of the option. Is there any other option? Yes, right. And what is that option? You will say, if you are if you want, like it is up to you. If you want, and if you are particularly wanting, then generally, in general, what you can say, that if this is one also, then also it is fine. I mean, one of the choice. It's not like both of the choices, right? If yeah, it is just one of the choice. So you will say that you need these many addresses. Then either this is 0, this is 1. I just need the host ID to be 7 bits. So either this block or this block. Let me choose this 0. Okay, let me choose one of the block. So let's choose one of the block, which is basically saying one. Sorry. So let me choose this one only, which is basically saying that your IP address is this. Then I mean your network ID is this. Then you can basically have this block. Now, can you tell me it's the slash notation, the good notation that we are having here, which is okay? Tell me, is this fine? Is this a valid slash notation to this? Does this represent the above block? Yes, right. I mean, here you need to have something which is having 0. Okay, so either you write 0, you write 10, you write 20. I mean, as long as you are having 0, it is fine, right? Or maybe you write, sorry, you write anything, maybe 5, or maybe you write 114.24.70 anything, maybe 50. Okay, can you write like something like this? Can you write something like this? Since it is more than 128, and that's why like this bit will be 1, definitely 1. So that's why this is not allowed, right? I hope you understood. Because this is more than 128, that's why this bit has to be 1. And more than or equal to 128, that's why this bit has to be 1. That's why these things are not allowed. So anyway, what we did, we were given some block of IP addresses, right? And then which is something like this. And then we said, like in this block 24.74, so this is 24. Now we said, like in this block I have I had some number of addresses, which are 256 addresses to start with, and then I have divided. Okay, so here I have 256 addresses. I have divided that currently into two parts, right? What is the first part? I have divided that into two parts, 128 and 128. I have said, okay, let's just take this as just one part, and this is another part. Okay, currently into two parts. Each one is having how many IP addresses? This is having 128. This is having 128. Now, what I'm going to do, I'm going to say that, okay, see, I needed 120 blocks for this. Okay, I mean for one of the for one of the my department, maybe electrical, computer science, or one of the division, I need 120 hosts. So I will be basically giving this particular chunk, which is having actually 128 addresses. Now what I will do, since I need to further divide the second chunk into multiple chunks, which are 10 and 60, right? 10 addresses and 60 addresses I need from here. Then I will be using this chunk. Is this okay to everyone? Can I use, maybe let's suppose I just need three addresses instead of 10. Let's suppose I need 3 addresses. Can I use here, how many addresses are unused? Maybe 8 or something. Okay, let's not go to the exact number, but let's just say 8 addresses are not used. Then can I use these 8 addresses? From this 8 addresses, can I use one of the block, these 3 addresses? Answer is no. Okay, so basically once we give that to some particular division, then like this slash notation is telling you that there are 128 addresses and you have to have those 128 addresses dedicated to one particular division. It's, if that is using those 128 addresses, that is fine. If not using, then it is okay. I mean, you cannot have, you cannot further say that, okay, this is 120 and then 8. You cannot divide like this. Okay, I mean, based on the slash notation, you have to divide. If you try to divide this into 3 addresses or something, you will not be getting a valid slash notation here. Okay, I mean, one slash notation says that you can, I mean, it is in 2 power, right? So here, how many addresses you have? You have 2 power 7 addresses. Okay, so it is 2 power. Anyway, even like once you give that to one of the division, like I hope that will be more clear with the examples, but then you cannot further divide it to, I mean, you can divide, but if it is using 128 addresses, then just 8 addresses you cannot give to something, right? Okay, maybe, okay, Nikhil, don't worry, let me just continue, maybe you will get to understand. So these are the 128 addresses that I have in this particular block, and then you need to divide that into 2 further parts. Now what is the bigger one, 60 or 10? 60, right? So you first have this block of 60, then you will say, like, that's how we have went to the classes, right? I mean, in the classes also we have divided into first class A. Why? Because it is the biggest one, then the class B, right? So let me just take the 60. Now tell me how many bits you need from the host ID. Yes, 6 bits, right? So maybe let me go through this. So you have taken this as 0. So I'm just representing with the pie chart. I hope that is okay. I mean, what is this pie or what is the circle? The circle is set of all IP addresses, right? If you want, you can represent this with the rectangle also, which means you can say these are the set of all IP addresses that I had. I have divided that into 2 parts. This is 128 blocks, and then I'm going to divide this into further maybe 2 parts or 3 parts, maybe something like this. Maybe I think just 2 parts should be enough, right? And then this is 64, this is 64. So I will give this to my one division, right? This to my second one, because it just needs 60. This to maybe the whole thing to third, or maybe if I want, then I can further divide this, right? Okay, or maybe the whole thing to third. Okay, or you can represent this with the pie chart. I mean, this pie chart and this rectangle both are same. So this is 1, which means that if first bit is 0, I will say it is 1, and then the second bit is 1 0, then I will say it is having 64, but I just need 60, that is fine. If the third bit, okay, or maybe second bit is 1 1, then I will say it is belonging to my third network. Now if you want, you can further divide that third network, right? You can further divide the 64 addresses into some other addresses if you want. If you don't mind, that is okay. So basically what is happening here, let me go here. See, okay, you had this. Now you said like these 24 bits are fixed, and then let me divide this into 2 parts based on the just 1 bit. So maybe you will say that this is something like this 0, and then slash 25, or maybe you can change this, right? 2, 3, 4, 5, 6, 7 slash 25, and then similarly something like this. Okay, and then you said that here you have 1, and then you said let me just divide this in also into multiple parts. Okay, this is 128 addresses, and then you will divide this into multiple parts, maybe just 2 parts for now, and then you will say if this is 14.24.74.10, and then these are the 6 bits, right? 1, 2, 3, 4, 5, 6. These are the 6 bits. Then you will say it is just one of the block. Similarly, so since these are fixed, this is 26. Similarly, you will say that okay, just a second. Right. So similarly, you will say if that size if instead of 10, if it is 11, then it is just another block, right? So if it is just 11, then it is just another block. Now my requirement is fulfilled till now, which means it is I will give this to, this is having 128 addresses, this is having 128 addresses, I will give this, this is having 64 addresses, I will give this, this is having again 64 addresses, I will give this. Okay, my requirement is fulfilled, but still if I want to divide, and if I want to use as less addresses as I can in particular division, then can I divide this into again 2 parts maybe, and it will be 32 32, right? Something like this, right? And then okay, how many addresses you need from this pool? Okay, let me take this to just this to the next page. From this pool you need 10 addresses. So you will say that since I just need 10 addresses from here, I will be I will be just needing how many host bits? 4 host bits, right? 4 host bits. So 4 host IDs I will be needing. And how many are available here? I think here 6 are available, right? So I will fix the again 2 bits here. So which means maybe I will divide, okay, directly. Let me just directly divide this into 4 parts. Okay, 1, 2, 3, 4. One is maybe something like this, and one of them I will give to my division. One is something like this, dot 1 1, and then these 2 are 0 0, and then these are anything, right? These 4 are anything. Similarly, another one will be something like this, and then these 2 are 1 0, and these 4 could be anything, right? Something like this. So this will be slash 28. This will be slash 28. Something like this I will divide into 4 parts. Okay, so there will be 4 parts, and then one of the part I can assign. So I can assign, let's suppose, this part to me C, or maybe I can directly assign this whole thing, the whole chunk, or maybe I can further divide. Okay, it is up to me, because they have not specified anything. Okay, again, this is just a sake of practice. You can just divide this network into maybe 7 parts. Okay, this is the network, and then you can divide this network into 7 parts, and then you can do this question as a number. Okay, this is this you might have done, or maybe you can do it again. Yeah. So let's just solve few of the questions, and then we will go to very interesting topic, which is forwarding of IP packet. Like, I mean, till now we have just seen a few concepts, like what is subnet, what is or like how to divide a subnet into how to divide a network into subnet and all. And now the only thing that is that is very relevant is that like whatever the slash notation is given to me, okay, it means that these bits and bits are fixed. Okay, once you understand that, then you should be able to solve any subnet question. Now let's first solve few subnetting questions, and then we will see that how to forward a packet. Given if a router is coming up with some destination packet, then how does the router take the decision to forward this packet to some network? And based on that, we will see that there is an idea of supernetting. Okay, supernetting in the sense like we are not actually actually combining something or something like this. It is just logical combination at some router level. I mean, this router or some other router might think that, okay, these networks are just one network, something like that. So first we need to see how does the router take the decision of the forwarding. Then we will see that how router can efficiently forward, and efficient forwarding means supernetting. Okay, subnetting is one of the way to reduce the entries in the routing table. It is just a logical combination. So before that, let's just solve few of the questions. Okay, so this question has been asked in GATE 2003, where they are saying the subnet mask for the particular network is this. Which of the following IP addresses could this belong? Could belong to this network? The subnet mask for the particular network is this. Then, okay, so they are saying AND, which means these two. Can these two belong to this network? Let's just check. What does this mean? How many bits are fixed? Okay, this is very interesting. They are saying 31. So generally, okay, in general, from starting in general, all bits are fixed. Maybe from starting n bits are fixed, something like that. But for the theoretical purpose, this is just a theoretical question, not a practical. In the practical sense, we don't do this. For the theoretical purposes, I can say, okay, this is the 32 bits I have, 1, 2, 3, 4, something like that, right? So these are the 32 bits I can have. So generally, I will say that initial n bits are fixed or initial x bits are fixed. But for the theoretical purpose, I can say that, okay, maybe some bits are fixed from here to here, maybe some bits are fixed from here to here, something like that, right? I mean, depends on our usage, but generally it doesn't happen. But for the theoretical purpose, I can have this as a subnet mask also. So it is saying that initial this 2 bytes are fixed, or initial two octets are fixed, and then you are having this 31 is 2 power 5 minus 1, which is basically 5 bits. I mean, from the 31 representation is this 1, 2, 3, 4, 5, and then these are the 3 zeros. So basically it is saying the initial 2 bytes are fixed, and then this is not fixed. These are all zeros, right? And these are all zeros. So these 3 are zeros, and these are all zeros. So what is fixed is this: these bits are fixed, and these bits are fixed, right? So can you tell me which two IP addresses belongs to the same network? What you need to do? You need to check that here. Okay, see here, these two are changing, right? I mean, you need to check that for these two IP addresses, you can find out the network ID, or maybe you need to check that, okay, these particular bits should be the same. So you check here, this is 172.57, this is 172.56. Since these two are not same, can they belong to the same network? Network ID will be different, right? If you take the end of on using the subnet mask, network ID will be different. So that's why they cannot belong to the same network. Okay. Can they belong to the same network? Let's just check. Yeah, 10 or 35 is saying yes, there is a chance, but we need to check with the 28 and 29. Since last, these 5 bits has to be fixed, right? If this is 28, these 5 bits, basically 28 will come in these 5 bits only. So I have to change these 5 bits to get this 29, right? Yeah, LSB is 0 and LSB is 1 here. So basically here also these 5 bits are not fixed. I mean, initial 16 bits are fixed, but these 5 bits are not fixed because of this 28 and 29 not same. Fixed means not same. Okay, so that's why this is not the answer here. Okay, since this is different, that's why this is not the answer. So D must be the answer. See here, these are fixed, these are same basically. And then if you represent this 129 and 161, okay, this does not matter to me. I mean, this can change, right? But if you just compare between 129 and 161, then it will tell you that, okay, 5 bits are same in this, right? Maybe I have the solution. So 129 is this and 161 is this. Just check whether the last 5 bits, right? Okay, last 5 bits are something like this, which are in fact same. So since the last 5 bits are same, so that's why I will say that yes, these two are basically belonging to the same network. Is this okay to everyone? Okay, so let's do this. An organization has class B network and wishes to subnet for 64 departments. So how many subnets it need? 64. So what should be the subnet ID? Class B means subnet must by default, these initial 16 bits are fixed. Now they want 2 power 6 subnets. So it means for the class B, right? For the class B, I mean, the subnetting could be either in classless or in the class full. So in the class full, if you do the subnetting, then these bits are already fixed. It is just like that. These bits are fixed. I need to borrow how many bits from the host ID? I need to borrow 6 bits. So basically 6 bits I will be borrowing. So the subnet mask would be B, right? Okay, sorry, if you take all these ones, not B, if you take all these ones, then I think a D. Yeah. Or if all of these are ones, or all of these 6 are ones, then D should be the answer. Okay. So let's see this. Two computers C1 and C2 are configured as follows. C1 has IP address this and network mask is this. C2 has IP address this and network mask is this. Which of the following is true? So C1 has this IP address and network mask is saying that initial how many bits are fixed? These are the 16. And then can you tell me this 128 means 1 followed by 7 zeros. So it means initial, like if I just represent with the backslash notation, 16 and 17. So it will say initial 17 bits are fixed. It will say 192 is basically 128 plus 64. So which is saying initial 18 bits are fixed. So here this C1 has an IP address of this. Basically, there is one network this, and I mean C1 is belonging to this network, which is having IP address this and slash 17. C2 is belonging to this network. Slash 18. Now let's just check if they are in the same network. So 17 means like, okay, this 2 if you represent, this will be 0 0 0 0 0 0 1 0, right? If you represent the 75, this will be, let me represent the 75. Okay, 75 binary is not written here, but yeah, if you represent the 75, it is 64 plus 8, 64 plus 11, which is 64 plus 8 plus 2 plus 1. So this is 2 power 0 is 1, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8. Sorry, 2 power 7, right? So yeah, 1, 2, 3, 4, 1, 2, 3, 4. So this is 75. And then if you just check, here 18 bits are fixed. So here 17 bits are fixed. So this is the network ID. So it should be 0. And here 18 bits are fixed. So it is 0, 1. Now, what does this mean? It is saying, see, there are two addresses that I have. Yeah, this question is little interesting, I think. One is this one. 197.2.53 slash 17. Another one is 203.197.75.50.201. Another one is this slash 18. So here this 2, if you represent in binary, it is 0 0 0 0 0 0 1 0. If you represent this 17 in binary, it is 0 1 0 0 1 0 1 1 0 1 0 0 1 0 1 1. Now it is saying that your network ID is this. I mean till this 0. It is saying your network ID is till this 0 1. So basically, it is saying after that whatever is there. So in this network, in this particular network, right? This is the IP address of C1. Okay, so basically there are two networks and there are two IP addresses, C1 and C2. Okay, C1 IP address is 203.197.2.53. C2 IP address is 203.197.75.201. So tell me, C1 belongs to which IP address? C1 belongs to which network? Okay, this is 2.53. So in this C1, like this particular network is saying this should be 0 and everything could change. So basically, this particular belong to the network 1, right? C1 is configured. Yeah. So basically, let me just call it as a net 1. This is network 2. So C1 belongs to network 1. Does C1 belongs to network 2? Network 2 is saying that it should be 0 1, but in the C1 it is 0 0. So it does not belong to network 2, right? Not network 2. Now let's just check for C2. Okay. Yeah, it is fine. Yeah. So for the C2, it is saying that it is 0, 1, it should be 0, 1. So it definitely belongs to network 2, right? Does this belong to network 1 also? Does this belong to network 1 also? Network 1 is saying it should be 0 and everything else you can change, right? It should be 0, everything else you can change. So yes, this is belong to network 1 also. So C2 belongs to network 1 and network 2, but C1 only belongs to network 1. So what should be the answer? C1 assumes C2 belongs to both networks and C1 belongs to just one network. So basically, it should be something like this. I mean, diagrammatically, let's suppose this is your network 1. Okay, this is your network 1, and in this network, actually, this is the whole network. In this network, you have sub part, right, which is network 2. So your C2 belongs to network 1 and network 2, which means C2 is here, C2 is here, your C1 is here, right? C1 only belongs to network 1, but not in network 2. So your C1 is here, C2 is here. So what is the answer? C1 assumes C2 is on the same network. C1 assumes C2 on the same network, but C2 assumes C2 is on the different network. C1 is on the different network. Okay, so C1 for the C1, what is the subnet mask? C1 is no like for the C1 this is the complete network, right? So for the C1 there is no network 2 because based on the subnet mask you will be deciding. For the C1 the subnet mask is /17. So for the C1 this is the complete network. So which means C1 will think that C2 is in the same network, but C2 does not know that C1 is in the same network. So C2 assumes that C1 is a different network because for the C2 this is the complete network. But for the C1, this whole thing is a network, right? This whole thing is a network based on the subnet mask you need to decide. So that's why C is the answer. Should I repeat this question? So see what is happening here. Let me know if you have any doubt. Based on that, I will repeat. Yeah, network 2 is a subnet. That is fine. Network 2 is a subnet of network 1. That's why C will be the answer. Okay, let me go through this question again. So basically, there are two computers, C1 and C2, and these are the IP addresses with the subnet mask, which means C1 thinks that this is the network that C1 is in because this is the subnet mask. So basically, this whole network is, let's suppose, network 1, which is having some range of IP addresses, and C1 is just one of the computer here. Okay, and it is basically having some range which is .0 or anything, right? Or maybe let me write .0.0 /17. This is your network 1, right? There is some other network which is something like this. This is 10 means 2 power 0, 1, 2, I mean 2 power 6, right? So it should be 64. This is the network 2. Okay. So there are two networks. One is network 1, another one is network 2. Now, C1 for the C1 thinks that it is in network 1 because the slash is given. So for the C1, the complete thing is a network, right? This complete thing is a network. Now, we have logically divided or like this like we have done the subnetting, and there is another network which is the network 2, which is subnet of this network, and then we have said that okay, C2 is here, okay, in this network 2. But for the C1, I'm exposing C1 with this particular subnet mask, which means I'm saying that this complete thing is a network. So for the C1, this complete thing is a network, and for the C2, only this thing is a network. Okay. So here the C1 assumes the C2 is in this or network, but C2 doesn't know that C1 is also in the network, right? So C2 will think that okay, C1 is somewhere else. So that's why C is the answer. Okay. Yes, that is true. So C1 cannot see after the network 2, which I mean network 1, or C2 cannot see after the network 2, which means for the C2, this is the complete network because it depends on the subnet mask. So let's do this question. The address of a class B host is to be split into the subnet with the 6-bit subnet number, what is the maximum number of subnets and the maximum number of hosts that each subnet can have? So if these are the subnet numbers, then what is the maximum number of subnets you can have? I think you can have 2 power 6 subnets, which is 64. And maximum number of subnets and maximum number of hosts in each subnet. Okay. So class B, it is class B, which means 16 bits are fixed. Remaining from the remaining 16 bits, which are your host ID, you have taken 6 bits for the subnet. So 10 bits are for host ID remaining, right? So which means 2 power 10 minus 2. So which is 1022, right? Okay, 62 subnets they are saying. What is the answer that is given? Okay, so 64 subnets and these many hosts are possible. Let me see the answer. This is becoming a very difficult question now. Okay, so I think like this is some controversial question because that 64 subnets are there. But if you have to have the host, then the number of hosts that are actually possible is 1022 only. I mean, you have to have some network ID. Otherwise, how you will identify the network ID, right? How will you identify the network? So maybe it should be 1022 only. As the question, like answer is also saying it is some debatable question. But anyway, like we know the concept. It should be 64 subnets because 6 bits are you have taken from the host ID for the subnet number. So 64 subnets are there, but you can have 2 power 10 total IP addresses, but from there you need to have 2 addresses for the one for the network ID, another one for the broadcast address. So that's why I need to subtract 2. So maybe it is little controversial question. Okay, in CN sometimes there are controversial questions, but anyway, like we can anytime challenge, and sometimes it is our luck also. Maybe they make it. I mean, they either give the marks to all, or they do not. It depends on luck, right? We cannot say anything. Okay, so I hope you understood the concept. Yeah, many times there is no luck. Okay, in a class B, network has a internet has a subnet mask of this. What is the maximum number of hosts? I think you can do it. So maximum number of hosts in a class B, subnet mask is this. 248 means this is basically 7. You need to subtract. I mean, 248 plus 7 is 255. So 7 is this one, right? So yeah, so I think these are 5 bits. Now you are having 16 plus 5, which is 22 bits you are having for the network ID. So you are having 10 bits for the host ID. So 10 bits for a host ID means 1022, right? Sorry, 11 bits or 10 bits? 3. Sorry, yeah, this is 21. 21 bits for the network ID because these are the 5 bits, and this is 16. Yeah, right. So 21 bits for the network ID, and that is why there will be 11 bits for the host ID, which means 2 power 11. These many number of hosts minus 2, 2 power 11 minus 2, which is 2046. So see here they are subtracting 2. They sometimes they are not subtracting 2. So like we will be subtracting 2 because for the implementation purpose we need to have the network ID and the broadcast address. Otherwise, how you will identify the network, right? Without the network ID. Okay, so maybe yeah, this is the good question. I think we should do it. I was about to say that we can do this question as a number, but yeah, we should do this question. Suppose the computers A and B have the IP addresses this and this respectively, and they both use the same subnet mask n. Which of these value n given below should not be used if A and B should belong to the same network? Okay, they want both of them to belong to the same network. Then which should not be used? Yeah, that's easy one, but yeah, interesting. So see here, see, you can have like this 113 representation is okay. This 113 will be 64. Can anyone quickly tell me 113 representation? Maybe just by Googling. 96 plus maybe 16 plus 1, right? 64 plus 32 plus 16 plus 1. Okay, just find out the 113 representation and 105 representation, then you can do this question easily, right? So yeah, 113 will be 2 power 0. Okay, just also find out the representation for 91. This is 1 1 1 0 0 0 and 1. Okay, so this is your 113. And what is 91? 1011 011. Okay, so this is 1011 1011 0 1011 011, right? Okay, no, we don't need for 105. So basically this is the representation for 113 and this is representation for 91. So just see how many bits are common. I mean, these all are common. So let me go to the next page. This is 10.105.1.113, which is 0 111 0 111 0 0 0 1, right? And then it is 105.191 and 0.105.1.91 means 0 101 0 101. Tell me how many bits are common till this point, right? Okay, so what should be the network ID that belongs to both of them? Maybe you can say 1 2 3 4 5 6. So or maybe this is 8 and 8 16, and then yeah 24 25 26, right? So 26 bits should be fixed, right? If you fix the 26 bits, then both of the IP addresses belong to the same network, which means you say like something like this. If you have this network, maybe this is 64/26, then this network contains both of these IP addresses. Do you agree? Now tell me, does this network also contain both of the IP addresses? Okay, just tell me. Does this network also contain both of the IP addresses? Yes, right. I mean this. I mean you can strictly like at max you can have 26. You cannot have 27, but you can reduce it. I mean this is just a super net, right? I mean this is a bigger network than this. So this network in fact contains this particular the whole network, like this whole network. Okay. Okay. Just tell me, does this network also contain both of these IP addresses? Yes, right. So basically you can have at most 26. So what you cannot have is 27 or something like this. So this is one. So which means okay. This is 24. So they are saying that which of the following and should not be used. So this is 24, right? This is 24, that is okay. This is 25. This is 26. This is 27. So which of the following is not allowed? I think D is not allowed, right? Okay. So I think D is not allowed. So D should be the answer. Yeah. Now tell me, Does this also have all of these IP addresses? Yes, right? Okay. Tell me. Does this have all of the IP addresses? /0? Yes, it also has, right? It is basically saying that nothing is fixed. Okay. I mean, you can change everything. In fact, this is some special address that we use for the routing purpose. Like I will tell you, that's very easy. Basically, one of the, if nothing is matching to this is called default address. I mean, nothing is matching to this, then I will be having this default address. This means that you can change everything basically. Okay. This is supernet of everything. This is containing all of the IP addresses in the world, right? I mean, this is saying that you can change everything. This contains all the IP addresses in the world, right? Okay. So maybe you can do these 2-3 questions as a homework. Okay, just one question is there that is remaining. You can do as a homework, right? Let's go to the forwarding of the packet, which is very interesting topic. Should we take a break? Uh, let's continue at 11. Okay. Yeah.